Good afternoon, classmates, and good afternoon, Sir Tano. We are the Group E, and we are going to report about the electrical hazards. So, what is an electrical hazard? To define the electrical hazard, it is a serious workplace hazard that exposes workers to burns, electrocution, shock, arc flash, arc blast, fire, or explosions. By identifying these hazards and understanding how they happen, we can take steps to protect ourselves. For example, there are types of situations that the workers are need to be aware of. Workers need to be aware of first uh, when they are contact with energized sources, because hazards regarding contact with energized sources are electrical shock and burns. Electrical shock occurs when the body becomes part of the electric circuit. It occurs when an individual comes in contact with both wires of an electrical circuit, one wire of energized circuit, and the ground, or metallic part that has become energized by contact with an electrical conductor. Second situation that the workers need to be aware of is when they are in the contact with power lines. Overhead and buried power lines are hazardous because they carry extremely high voltage. Fatalities are possible as electrocution is the main risk. However, burns and falls from elevations are also hazards that workers are exposed to while working in the vicinity of high voltage power lines. Third situation that the workers need to be aware of is when they are using improper extension and flexible cords. Normal wear and tear on extensions are flexible cords and flexible cords can loosen or expose wires, creating a hazardous condition. Hazards are created when cord connectors, receptacles, and cord and plug connected equipment are improperly used and maintained. If the electrical conductors become exposed, there is a danger of shock, burns, or fire. Since the human body is a good conductor of electricity, as a result, electrical current can easily travel through it. There are three main types of electrical hazard, which are the electric shock, electrical burns, and arc blast. Arc blast is the effect of the blast. Understanding the basics of this hazard is critical in enforcing electrical safety in the workplace. So going to types of electrical hazards and how it occurs, uh, there are mentioned three main types of electrical hazard. First is the electric shock. How does it occur? Electric shock occurs when a body becomes part of an electrical current. Example of this situation is when a worker or a person may come in contact with both conductors in a circuit. Another is when a worker touch or accidentally touch a live wire and an electrical ground. Another is when a person may provide a path between an ungrounded conductor and the ground. And lastly, it is when a person may provide a path between the ground and conducting material that is in contact with an ungrounded conductor. So, the severity of electric shock is related to four elements. If the combination of these four elements is just right, the shock can be severe or lead to electrocution. So, here are the four elements. First element is the amount of current. Second is the length of time current is present. Third is the path of current through the body. And lastly, frequency of the current. The amount of the current depends on the potential difference and the resistance. The effect of the current in the human body range from temporary mild tingling sensation to death. Voltage is important only in that it determines how much current will flow through a given body resistance. The, the current necessary to operate a 10 watt bulb is 8 to 10 times more current than the amount that would kill a person. A pressure of 120 volts is enough to cause a current flow which is many times greater than that necessary to kill. The second type of electrical hazard is the electrical burn. Electrical burn is the common shock-related injury. Is this electrical burn? Burn suffered in electrical accidents can be of three types, and these are the electrical burns, arc burns, thermal contact burns. So in electrical burns, it is the result of the electric current flowing in the tissues. These burns may be skin deep or may affect deeper layers such as muscles and bones. And the second type of electrical burns is the arc burns. This occurs and a result of high temperatures produced by electric arcs or by explosion close to the body. Third type of electrical burns is the thermal contact burns. It occurs when burns normally experienced from the skin contacting hot surface or overheated electrical conductors, conduits, or other energized equipment. Tissue damage is caused by heat generated by the current through the body and is often immediately classified as third-degree burn. If the energy delivered by the electric shock is high, the body cannot dissipate the heat and the tissue is burned. Typically, such electrical burns heal slowly. So the third type of electrical hazard is the electric arc blast. So when does the electric arc blast occurs? Electric arc blast occurs when the current is strong enough. The blast effect that can result from arcing can cause injuries and Start files. The power arc is discharge of electricity through a combination of ionized air and vaporized conductor material. The conductive material is vaporized by temperatures in an arc which can be as high as 35,000 degrees Fahrenheit.
So these are the causes for possible accidents in a working area. First is the inadequate wiring. So it is very common especially sa mga uh, balay na kana gani gitaprag lahaw sa puste. So what they're gonna do are to tap illegally kana gani. So what they're gonna do is ilang balay connection nila sa balay ilahaw og tap diha sa poste, and sa ilang balay pa gyud is wala nila gitarong og wiring. So what is gonna happen is kana og gitarong og wiring possible kana mabuto na sparks. So magana siya first and foremost na and most common as well the cause for mga accidents. Next is exposed electrical parts. So sa kana kaning sa mga mall, we could actually see mga wirings diha nga parts and that is actually the best example for mga electrical parts o electrical wirings nga gitago jud. Although makita na to siya it is makita na to siya it is properly um, gi-place man sa dugtarong siya ug dili siya ma-reach og bisag kinsa nga people ba ana siya. Next is wires with bad insulation. So these are the wires nga wala gitarong og kanang insulate siya or iyang insulation is kanang yung mga baga na kay siya metal nga wire sa sulod but then iyang mga iyang insulation is not proper or kana galing for example nakakita kag short circuit diha and then imo siya giputol and then nakalimot ba ka dira og electrical tape or any kind of insulator nga atong pwede itapak diri balik. So that is very dangerous as well. Next is the electrical systems and tools that are not grounded or double insulated. So kana gani sa atong saksakan sa kana atong adapter no or sa for example sa atong mga charger or the best example for this is kana gang saksakan nato nga para gamit ato sa computer na magud na siya kanang ikatulo nya sometimes kuhaon nato siya kay dili siya mo paslag sa atong wall outlet. That is actually for safety precautions to ground sa imong computer aron di maguba. Next is overloaded circuits. One thing I know of this is for example sa America their wall outlets there ilahang mga kurente kay mudawat ra og mga 110 volts nga devices. So for example, American citizen maybe mupalit og mga appliances gikan sa China. Then ang napalit nila nga device from China or appliances from China is kanang 220 volts ang kaon sa kuryente. So kana mag-overload jud siya. Kay dili siya compatible. Buto siya imagine 110 ra ang ma-provide sa imong outlet sa imong kuryente but ang gikaon sa imong appliance is 220 so kana mabuto gid siya na. Next is damaged power tools and equipment are electrical hazards. So kani siya siguro one thing example of this is kanang mga dili kayo ka for the unfortunate people, let me say mga unfortunate nga mga workers nato no nga kanang ako na lang sa ni preserve kay kanang kasman niya. Of course, we know as mga engineering students, we know nga mahal gid nato mga tools. So kana aron makatipid, ato na lang ni ayuhan preserve just. So, sige na tog preserve sa kadugay niya kay damage na din na siya. And kana that might cause accident na noon and kana worst case scenario is mapanoy hinungdan sa kamatayan ba ana siya no. So that is very dangerous as well. Next is using the wrong PPE. One time kakita lang ko kanaging mga mangayo og poste no kay sometimes kita ko naiguban niya dili mo gamit og di ba naman sila proper PPE using gloves kana ilang gisulob ilang sapatos should be kanang steel to gid na yan and then some of them kayo kita na mga mag t-shirt lang yan na ba and some of them kay marag ilang gloves kay kanang gloves pang masa. So that is really very dangerous, guys. Supposedly, the gloves that should be used while working with electrical wiring should be kanang rubber, no? Ayan. So using the wrong PPE could lead to any accidents, electrical accidents, and that is very hazardous as well. Not using the right PPE for the right work. Next is using the wrong tool. Kana magamit lang kag tool nga for example ang kayo kay aning mga pliers na naramay pliers for kanang mechanical use only so na pliers nga kanang metal gid sa tanan dayon mao siya imong gamiton for something to pagtuyok sa tornilyo siguro yan no and then upper mga pliers for electrical use kanang pliers for electrical use kay ang mga handle kay rubber so kana although mura siya the same no pliers gyapon siya but the use and the purpose for its use is different. So that is very dangerous po. Next is defective ladders and scaffolding. So defective ladders, the most common for this kay kana sa katong example ako ganiha katong mga magtrabaho sa mga poste magamit sila ladders. If that ladder is defective, that is kuya pud gihapon matumba na yung ladders diha kalit ikaw imong kapyutan ay kuryente na lang so syempre yung kuryentehin jud ka. So that is very kanang risky sa diayo. And the next one is um, ladders that conduct electricity. So, again, mabalik ko sa example sa katong mga mag-work o mga poste ka ng mga taga-Veco, yan na, no? Kaya ilang mga kakita na to, hala, nganong metal na siya, di ba, conductor mo siya electricity. Actually, that kind of kanang ladder is safe ra. Makita niyo sa tumoy sa ladder no kay na siya insulator dito na plastic, so that is very safe. So the purpose of that plastic no kay once mo-connect siya sa wire mo isandig dito sa wire dito siya mukanda kag electricity padung sa bottom sa ladder di siya ko kanda og electricity dito sa mga tao nga mangagi or sa mga kinsa ba, especially if ting-uwan, so kana siya. Next is electrical hazards can be made worse if the worker, location, or equipment is wet. And if basa kaya na siya, water might not be that good conductor, but water is still a conductor. So makurentihan gyapon gud ka sa sugod pagkabata pa lang nato no kay always kita i-remind sa tong parents nga ayog kupot sa kurente kay basa imong kamot. So kana pa lang that is a very good kanang lesson ko lang ever since nga pagkabata pa lang good. So might as well we apply that to our workplaces pohon as mga engineers, no? Okay. So these are the possible our mga causes of our possible accidents in our workplace. Next, so kana in a worst case scenario if makurintihan yun ka, di yun mapugngan niya makurintihan ka, so syempre lailasa na sila kanang current. So here I have the table for effects of electricity or electric current in a human body. On the left side we have the current kung unsa siya gikusgon, and then on the right side is the reaction as to how our body would react to that current. First is 1 milliampere. So diri ang mo-react sa imong body diri is imong perception level pa lang. So mura kag gitikon pa lang ba, so hinay pagit yan ni siyang 1 milliampere, no? So next is the 5 milliamperes. You would feel a slight shock, and then it is not painful but disturbing. Siguro one example ano nino kay kanaging sa lighter na siguro kita ni agim guro tanan na ni except sa mga kuan ka rin sa um, mga bata-bata pa. So kana siya na kanang isa lighter niya gubon mo tanan no, then kita man tag kanaging murag mo spark something ya duwa-duwaan tanan niya tay pakurintihan nato mga playmates pagkabata nato. So yan na siya, slight shock but it is not painful. However, on average individual can let go. However, the strong involuntary reactions to shocks in this range can lead to injuries. So kana maka-feel gid ka mukaatay gid ang kuryente sa imong kamot ba, so mulupad yun mga kamot ani. Yan na sa next is from 6 to 25 milliamperes for women. It is a very painful shock and muscular control is lost. Murag ganun mo tikig na kadiyot. Next is from 9 to 30 milliamperes for men. This is called the freezing current or let go range. So, this is the time kana yung murag nakita nato sa salida ni kirig na pero ikaw magkirig buhi gyapon. Yan na ba. Next is from 50 to 150 milliamperes. This is extreme pain. You would experience respiratory arrest or severe muscular contractions. So individual cannot let go, and this is the time death is possible. So diri na gid ni kanang mga kiyo na no, especially kanang mga nagwork sa mga poste, sa mga veko ba. So that is actually very dangerous. That is why we need to use some PPEs, good proper PPEs, proper tools, and safe kanang mga ladders. Next is from 1,000 to 4,300 milliamperes. Your body would experience ventricular fibrillation. The rhythmic pumping action of the heart ceases. Muscular contraction and nerve damage occur. Death is most likely. Kani, sure dead niya. Yan double dead na gid yan. Okay, kusog na magit yan siya. The last one would be the 10,000 milliamperes. You would experience cardiac arrest, severe burns, and probable death. So, mana siya ang possible effects. However, in our working area, common sense na lang gid sa if kita ka nga electrical hazard gid na siya imong gitrabahuan, syempre di na ka magunahon na nga okay ra ni 1 milliampere ra ni di ra ni kamatay or 5 milliamperes ra ni. Of course as human as we are, mulikay na lang gid ta ana, no, especially kita as engineers maglikay na lang gid ta mga aksidente because prevention is better than cure. So man imo mabuhat if nakurentihan na ka, syempre di na mo i-measure kung ano man sa to siya 5 milliamperes kabiha sa ni, di ba? So yan na, regardless of how strong the current is, syempre our atong pagka vigilant sa atong workplace should always be at 100%. Next, it is essentially invisible. Electricity kay syempre makita ba gud nimo not unless if kanang kidlat na gid na siya or kanang kusog na gid kay, no, but even though ang electricity kay di makita, electricity has long been recognized as serious workplace hazard, exposing employees to electrical shock which can result in serious problems that includes electrocution, serious burns, or falls that result in additional injuries or even death, as well as electrical arc flash and electrical arc blast. So that's it for the causes and possible effects of electricity in our body.
Let us now discuss on the control measures or the precautionary measures. So we have 5: the insulation, guarding, grounding, circuit protection devices, and safe work practices. So first is the insulation. All electrical cords should have sufficient insulation to prevent direct contact with wires. In a laboratory, it is particularly important to check all cords before each use, since corrosive chemicals or solvents may erode the insulation. So, with the use of insulators, they are the materials with high resistivity or high resistance that isolate conductors to prevent accidents from exposed electrical current and to separate energized parts of an electric circuit and confine the flow of current to wires or other conducting path as desired. So examples of insulators are porcelain, Teflon, plastic, rubber, polyvinyl chloride or what we know as the PVC, ceramic, glass, and other non-electrical conducting materials. So next is the grounding. Only equipment with two-prong plugs should be used in the laboratory. The two-prong provides a path to ground for internal electrical short circuits, thereby protecting the user from a potential electrical shock. So, electrical grounding creates a backup pathway that provides an alternate route for the current to flow back to the ground. So, it is understandable that when there is a fault in the electrical wiring, grounding allows electricity to pass through an alternate route to the ground to prevent any electrical accidents. So, an example of electrical grounding is that a generator will say na be sure to attach to an earth ground before using, or an appliance might warn do not use without an appropriate ground. So mao to siya mag-create og pathway, alternate pathway sa electricity para adto siya mo agi when there is a fault in the electrical wiring. So next is guarding. Live parts of electric equipment operating at 50 volts or more must be guarded against accidental contact. Plexiglass shields may be used to protect against exposed live parts. So, live electrical components daw operating at 50 volts or more must be guarded with covers or permanent barriers to prevent accidental contact between workers and those live electrical devices. So that is why they create this yellow like a perimeter fencing with warning signs that says danger, high voltage, to warn the operators or users that there is a high voltage in the system. So an example of this is usually makakita ta like sa makakita sa daan, and then there are mga live electrical areas with warning signs nga danger, high voltage, to keep out the mga civilians from entering para to avoid accidents. So next is the circuit protection devices. Circuit protection devices are designed to automatically limit or shut off the flow of electricity in the event of a ground fault, overload, or short circuit in the wiring system. Fuses and circuit breakers prevent overheating of wires and components that might otherwise create fire hazards. They disconnect the circuit when it becomes overloaded. So examples of circuit protection devices are cartridge type with glass tube and wire fuse link, fiber tube, ribbon type, copper fuse link, knife blade cartridge type, plug type with ribbon fuse link. So mga fuse in several households or circuit breakers are there to control or limit the flow of electricity when there is overloading. So that is the function of circuit protection devices to prevent any accidents from happening. So finally, the safe work practices. So dire na to makita kung giunsa na to pag-practice ang mga safety precautions when operating mga electrical systems or operations. So first, keep away from the energized or loaded circuits. Next, sources of electricity and exposed circuits must be guarded. Next, disconnect the device from the source in the period of service or maintenance on the device. Disconnect the power source before servicing or repairing electrical equipment. Handling the equipment that is plugged in, if it is necessary, hands or contacting parts must be dry and wear non-conductive gloves and insulated soles shoes. It is safe to work with only one hand. Keep the other hand away from all conductive material. This step reduces accidents that result in current passing through the chest cavity. Utilization of electrical equipment in cold rooms must be minimized due to condensation issues. If it is imperative to use such areas, the equipment must be fixed on a wall or vertical panel. If the device interacts with water or other liquid chemicals, equipment must be shut off power at the main switch or circuit breaker and unplugged. If an individual comes in contact with a live electric, do not touch the equipment, source, cord, or individual. Disconnect the power source from the circuit breaker or pull out the plug using a leather belt. So these are the safe work practices or the safety tips during electrical operations. So that would be all.